Hello, everyone, and thank you for attending today's webinar. Get ready for off-grid success with the newest innovations by the off-grid experts. I'm Billy Lute, Associate Editor of Solar Power World. Now, before we get started, there are a few things you should know. This webinar will be sent to all registrants so you may view it again. Slides are available to view at any time via the resource widget on your screen. Submit any questions related to today's webinar via the Q&A widget. We will try to answer these during the webcast. If we do not get to your question, our presenters may reach out to you after the broadcast. And finally, if you're watching this on demand, you can still use all of these features. So let's get started with today's webinar. Get ready for off-grid success with the newest innovations by the off-grid experts. Today's speakers are Bill Malame, Director of Product Development with Morningstar Corporation, Jim McGrath, Director of Sales with Morningstar, and Brad Burwald, Senior Product Manager at Morningstar. And now, I'll turn it over to Brad.
Okay, thank you very much, Billy. Really pleased to be here and excited to present these exciting new products to everyone. So today we'll be talking about our SureSine off-grid inverter and also our GenStar integrated DC system controller. So with that, I will begin and give a little bit of background about Morningstar as a company. Hopefully many of you are quite familiar with us. We've been in the industry some time with over 4 million products sold since 1993. And we've been selling globally. A big advantage of DC system solutions is they're ubiquitous and used throughout the world. So all of those mission critical applications, such as anything from offshore oil platforms in the North Sea to applications such as telecom in the Sahara Desert. We even have projects in place at both the North and South Poles. And we've really been proven in the most extreme environments because of our focus on product quality and, of course, our experience in off-grid. And a lot of this has driven our highest reliability rating in the solar industry because we have over a 99.9% reliability rating for the hardware. Our location is in a commercial office in Newtown, Pennsylvania, sales, marketing, and HQ. And then we have a significant engineering office in Jessup, Maryland, where we have laboratory testing, all of engineering and design, as well as a lot of our certifications work is done as well. We have a U.S. warehouse location in Los Angeles, California, and then manufacturing done internationally in Taiwan. So some of the off-grid focus that Morningstar has in a lot of different industries is covered here, and you can see some of the diverse applications that we work in, anything from rural development or rural electrification. All industrial markets are covered, such as oil and gas, telecommunications, security, lighting systems. We also have a very strong presence in transportation signaling, such as those used by Department of Transportation across the United States and in other countries. And then lastly, commercial government and military research are also areas in which we focus. Now, some of the differences with Morningstar are that really make us stand out, and it's really our design ethic that we apply to pretty much everything we make. First of all, that's a smarter digital design overall, and this would be really just using the latest processing technology, using what we would call a native embedded design for control of the power electronics. We don't cut corners by using integrated circuits or off-the-shelf chips. We design all the software ourselves for really exact control over the power electronics. Another feature of our controllers is they are laid out for performance. So we do not use something like an off-the-shelf heatsink. We do a lot of custom designs, chassis, closures, aluminum extrusions to make sure that the products are specifically built for purpose and that they're going to do a perfect job in keeping that product as a high performer once out in the field. We use overspec components, meaning that we integrate a design margin from an engineering perspective so that the products have adequate rating for these the abuse that they may sustain in the industry in these applications. And of course, with those custom extrusions of aluminum, that's really to drive our fanless design, which it really enhances reliability and ensures that the product is going to be efficient and it's going to last the test of time. It's very common for our products to have an easy lifetime in the field of 15 years or more. And I think that's proven by our over 29 years of experience in the industry. We have a dedicated engineering center, as I talked about earlier, with all of our R&D test lab. EMI is done in-house, which is not too common. Also, our certification process is also handled largely in-house for a lot of the rigorous testing and certifications that the products have. We built to ISO 9001 standards. And then lastly, all of our quality control really provides a direct test report for almost every product that we make, so we can trace quality issues and ensure that they're going to perform in the field. Okay, so that's a little bit about Morningstar. So with that, I will now hand over the presentation to Jim McGrath, who's going to be talking about our SureSine product.
Thanks, Brad. It's really exciting times at Morningstar. We've got a lot of new products, the GenStar, the SureSine. We've been in this off-grid segment since 1993, and this is a fantastic, exciting time to extend both the charge controller and inverter segment. And the inverter segment is it's not new to us. We've had small inverters. We call it the SureSine Classic, but we only had 2 versions. You see the little photo down at the bottom, and we're still offering that. But it's through the years, we've had it out for about 15 years. It's been wonderfully accepted product around the world. We've only had it though in 300 watt, 12 volt models, in the international 230, 50 hertz, and then in the US or North America 120, 60 hertz. There's only been 2 versions, and then customers have always been asking us, hey, can you guys make 600 watt, 24 volt, or 1000 watt, 48 volt, or whatever. There's a whole big world of these off-grid inverters out there, and so now we are really addressing it head on so that our customers can have a seamless system integration with our existing charge controller line, and it feels good to have Morningstar quality through and through your off-grid system design. And that's really the heart. What Morningstar really has, our reputation is about quality, about reliability, and our service and support. And this is just going to enable installers, consumers, industrial customers to use this SureSine line in all of their off-grid applications. So it's really exciting times for us. We've again instilling this superior industrial grade design philosophies into this SureSine. We're not starting from scratch. We're just extending the line and doing it in a big way. So, system level integration communications are part of this, and we're taking on new comms into this inverter line that are often requested in the industrial segment and the consumer segment. Particularly, with industrial segment, they're looking for things like Modbus communications via serial interfaces, or Modbus IP via an Ethernet interface, or even now CAN bus. So we're integrating all of these comms in here to make it really robust for the industrial commercial user who wants every little piece of information. We're doing it again in worldwide voltages and frequencies, all over the world. We're going to be able to support our customers. So here's an example. This table represents all of the worldwide types that we have. Battery voltages, you look at the first 3 rows, you're looking at battery voltages of 12, 24, and 48 volts up to 700 watts at 50 and 60 hertz, and just a wide range of voltage levels. You see 120 volt for North America, 127 for Brazil and Philippines, and then there's 220 volt for Brazil and Philippines, and 230 for most of the rest of the world. So these 3 versions, these 150 watt, 300, and 700, come with the Type B connector, which is a standard 3-prong that's commonly used in North America, or the international version, which can accept just about every single plug anywhere in the world, and then hardwire versions. And the hardwire comes with a unique safety cap on it as well. So it's really nice to have that flexibility to use hardwired versions in more industrial settings, or perhaps the receptacle versions in consumer settings. And then in higher battery voltage models, 2448, we offer the 1000 and 1250 watts. And these are hardwired because they're generally powering multiple loads at that point. So, to be able to add AC distribution outside of the inverter is very important at those power levels. And then finally at 48 volt, we're at 2,500 watts, a really, really big inverter for that'll serve a lot of unique applications, both consumer and industrial. So all in, for around the world, we're able to support. We have gone through the design and certification, 78 different versions. It's quite compelling. We're really excited about offering this to our global customer base. And of course, these are overbuilt designs. They're low frequency toroidal transformers, not high frequency. High frequency has a number of problems, and these low frequency are just rock solid, reliable. We have a standby function, which reduces power consumption to really low levels when the load isn't active. And then the hallmark about Morningstar too is fanless convection cooling in all our products. So it's got a pretty formidable aluminum heat sink around it. We design our power electronics especially carefully with the proper thermal, the highest efficiency components to begin with, and then we design the thermal, the casing on it itself to radiate all of the heat that's generated. And fans, they fail. They bring in contaminants. They make noise. They're just generally undesirable and shorten the lifespan of products. So it's good to get rid of them. And you never get them in a Morningstar product. So we're particularly proud of that. And of course, all of these terminal types you can see in these photos showing, this North American Type B, the universal, and then the hardwire. So you get quite a lot of flexibility. And then you also have a lot of certifications. There's the IEC 62109s, Part 1 and Part 2. There's the IEC 62368, which is more or less for a safety and standard for you might often see on rectifiers, and then UL 458, which is the mobile standard. So and UL 1741. So we've really covered the bases on the certifications. These things can also be controlled remotely, turned on and off through an input on this remote dry contact. So it's convenient if you're setting this up where you want a remote switch just to turn on and off the output. It's got that capability. And then there are a lot of manual dip switches as well that you can, for example, set the low voltage disconnect to one of several levels that are preset, pre-configured, or maybe the low voltage reconnect, and various alarms can be controlled via these dip switches. So you got a lot of comms too. RS-485, which is you generally communicate Modbus RTU protocol over that, USB interface, Ethernet interface for Modbus IP. You've got the MS-CAN interface, and then everybody wants Bluetooth, and so we've got it here. Whether consumer or industrial user, you're going to love the ability to use an iOS or an Android app and enjoy the ability to have a nice color display on touchscreen right on your cell phone or any other Bluetooth connected device. So it's really a complete communications package. So we're really excited, and our customers so far have just been thrilled about these new capabilities from Morningstar. Pass it back to you, Brad.
Okay, thanks very much, Jim. Really appreciate that overview. And as you can see, we're all really excited about the very global applications that this product can support. So what I'd like to do now is let's talk further about the SureSine, but take a deeper dive into some of these features that Jim kind of introduced us to. We want to make sure you all understand, what is possible with the product. So again, this is an off-grid inverter, DC to AC. It's really designed for remote power applications, and in all of the wattages and battery voltages that we've discussed so far. So a few of the standouts here and some of the features is, first of all, the fact that we've got really oversized design. The toroidal transformer is really there to provide that kind of surge or boost capability. Generally, it's about a 2x surge. which is, fairly unusual for a product of this size that gets down to 150 or 300 watt ratings. And that's really so that you can provide power for, continuous loads that may have a little bit of a overrating when they need to start up. And then it's also going to handle products such as motors, that have a high inrush current. A locked rotor pulls a lot of current during startup, and we see those industrial applications, valve actuation and industrial process control. They need that surge, and we want to make sure it's going to be delivered here. Also, the communications are, of course, all in the end there, both IP as well as serial, and also introducing Morningstar's new MS-CAN proprietary bus, which provides the ability of our products, the SureSine and many others, as you'll see, to communicate with each other. So that digital control gives it, a lot of advantages of, 1 + 1 = 3 in terms of building a system, because you'll see they work even better together. And then lastly, the digital control that I talked a little bit about earlier with these products is something you'll see in this inverter, in that it has the ruggedness of the low frequency design, but still with, signal or cycle by cycle sine wave control, using that processor, using inbuilt code in order to provide very tight regulation, low noise, really important in telecom applications, and really strong voltage stability, even when the product's under heavy load. A lot of products, they look great, the SureSine, when they're just turned on and there's not actually a load on them. But what are they doing when they're at 3/4 or even full power? You got to make sure that quality continues. So what we're really trying to convey with this product is it's not simply an adapter, an AC power solution in the field. So with the power ranges and the battery voltages available, it gives you a building block you can utilize for everything. As Jim said, the SureSine was a really loved product in the field, but there were just a lot of cases where the battery voltage changed or more power was needed and it couldn't be a fit, and they had to seek other options. And luckily, that's no longer a concern. It's available in these specific voltages. As we said, we do work all over the world, and markets like Brazil, the Philippines, even Japan, with their varying grid applications and dependencies of 100 volts, is something that's really different in the field, and we want to be able to make sure that there are solutions around the world that we can handle. The hardwire solution really is a bit unique in a product of this size, because it gives the installer the ability to provide a custom installation and actually connect not just the outlets, but the hardwired installation to an existing system. And we even give the ability to change the neutral bonding. Typically neutral is grounded, but it can be left floating. The hardwired option gives you the ability to wire it into pre-existing systems, or to actually provide that neutral bond and do a brand new hardwired installation as well. So it really has a lot of flexibility. So to talk a little bit about communications in detail, you've heard a lot of the terminology, but what does a lot of this actually mean? Well, Morningstar's been using Modbus communications for many, many years. It's really a standard in the industry. It's something that's been adopted by energy management systems and by the grid tie industry. It's the communication protocol of choice for industrial SCADA applications in the petrochemical and oil and gas markets, and it's available in both serial as well as IP-based Modbus, which would, of course, move over Ethernet. And that's available on the 700 watt and up versions of the SureSine. So having that Modbus capability, an open standard, and of course, really strong documentation published by Morningstar allows a lot of our customers to really make it a product that they can build a solution around, for OEM integration, or to get data themselves to add a lot of value to the system, beyond what's already there. As I mentioned before, Morningstar's MS-CAN link, it provides, again, very high reliability. It provides the speed, and it provides the multi-drop busing across the entire system that all of our products can communicate on. So not only can we turn the SureSine on and off, we can also get data from the device. We can synchronize it with other things that are happening in the system. And most importantly, gives us the ability to even provide firmware updates or other changes in the future. So those are all really important. And we see MS-CAN as being something that's going to be a really critical part of our entire portfolio going forward. And then last but not least, a remote contact closure. While simple in nature, on-off auxiliary control, it's one of the most utilized ways of actually controlling a lot of devices in a system. So using that dry contact, you can turn the inverter on and off using a simple control from almost any other device. So as I had said earlier, that integration between products is really key. And what we often see is that the inverters, because of their high current, when current switching is starting to be used, DC current control, you start to see really heavy currents that don't really work well with relays. And in giving that auxiliary control to the product, we can now offer it using that signal contact or using MS-CAN's direct digital control. And this is something that we had, we had the dry relay contact on the original SureSine, and by adding the MS-CAN digital control, a lot of benefits have been enhanced. So you're going to hear more about the GenStar integrated DC system controller very soon, but you can see here as an example of where the SureSine can be controlled, even multiples of them, along with your DC loads, all by a single system controller that has visibility on power, net current management, and of course your low voltage disconnect functionality. And then designing a product for a long operational life is really important in our markets. As we said earlier, with the geography that we cover and the remoteness of a lot of these applications, they may be in the ocean floating on a navigational buoy. It could be in a mobile trailer being used by, a security, police force, even the military. We have to make sure that these products are going to stand the test of time. So some of the things that we integrate in there, of course, are fanless convection cooling, but also we're choosing products that are really rated for higher temperature, specifically capacitors, often something that's neglected and are often very prone to high temperature failure. So we kind of push a lot harder for higher rated products there. And then it's really common for us to provide mean time between failure data calculated from all of our components and from testing and analyzing our past reliability track record to make sure we can give values that customers can count on when they're working on really well engineered projects. Also lab-based accelerated lifetime testing, knowing that this product is going to withstand thermal cycling, vibration, all of these things are efforts that we take ahead of time and then share with our integrating partners so that they can rely on a really well-developed solution. And then you'll see in the superior thermal performance of the products that of our 300 watt rated SureSines, that they have a full nameplate rating. And it is really going to already come in at 45 or 50 C at full power, depending on the model. So in other words, if 25 C is your kind of standard room temperature, we expect all products to work at that temperature. But in the field, 45 and 50 C is more common, and that's where we want these products to be able to perform at. And then you can see the same with the 700 watt and larger units, typically providing that same rating between 30 and 45 C. Now, the most important aspect is that we've done the efficiency testing, and we'll give you the ability to see what D rates need to be taken into account up to 60 C, which is a very high temperature. But as we said earlier, with installations in Africa and the Middle East, you need to know what the product is going to perform at those higher temperatures. And we give you the design data to make those decisions. So as Jim mentioned earlier, the fanless issue is really a very important one. And you can see in the picture below, whether you've opened a PC or you've come to a cabinet in a remote power system after many years and you've seen all the wonderful contaminants and debris that have been brought into a product, even though they're sealed and there's various, degrees of ingress protection, things still happen. And when you've got a fan, you're actually contributing to that. You're creating negative pressure inside the cabinet and everything outside wants to come in. And we want to prevent that with these fanless designs. Okay, so we use that passive cooling. We have a high degree of thermal modeling that we use inside of the products to make sure that the heat sink is adequate. You can measure it, watts in, watts out. It's designed right the first time. And then, of course, the advanced power electronics that we discussed, they not only are built for reliability, but they're also built for efficiency. When you install a system in a remote application, hopefully you're not going to come back and have to visit it for years. We've seen systems go through multiple battery changes over time. But the one thing that happens day in and day out is the power usage, whatever efficiency is in that system, is going to be impacted day, week, month, or years into the future. So a low efficiency design is going to continue to hurt you throughout the life of the system. Whereas high efficiency gains, you could be saving the equivalent of tens of kilowatts of energy, battery cycling, all of these, aspects that, kind of contribute to the aging of the system by just choosing high efficiency components in the beginning. Also, low self-consumption, the ability to turn the product off when not needed and put it into a deep sleep state where it draws only milliamps of power really aids these designs. As I mentioned earlier, the digital controlled sine wave output, something called total harmonic distortion, something that measures the quality and the sine wave's ability to maintain its form even under heavy load or noise, is something that's really critical. And in a lot of the applications we serve, such as telecommunications, they can't stand noisy power. So in many cases, we're exceeding often what the grid can provide. And that's important. Also, of course, working in extra wide battery operating voltages. So batteries, even lead acid, it's going to have a varying degree of temperature compensation. Lithium is a lot narrower, but regardless of the chemistry, we want to make sure that all of these products are off-grid ready. Now, the global certifications, we touched on this just a little bit, but of course, working with the labs for global compliance, ETL for safety, and basically ensuring that the product is designed well and designed so that it's safe to use. And all of those voltage ratings and specifications are reviewed closely by the lab. IEC 62109, of course, also for safety, but with a much more global perspective. The mobile standard UL 458, and then specifically for telecommunications and IT, both UL 6950 and 62368. And that's really much more of a performance standard as well for quality and for low noise. So all of those are intact in these products. Here's a quick look at the specifications. I know there's a lot of data here. I don't expect everyone to take it in now. Of course, the data sheets are available for this product, but a few things that I just wanted to call out here is not only the breadth of products available, but if you take note of the power surge capability, you'll see 2x surge. So for all products, 300 watts can run at 600 watts, for an extended time to start those heavy loads, and then on up to our 2500 product, which can surge to 5,000 watts continuous. The operating temperature range 60 C, as discussed, and then also take note of the very low self-consumption values. And really, when you don't have a fan, those fans can account for 8 watts themselves, and just not having those, in the design keeps them extremely low in power. Okay, so that's just to touch a little bit on some of those certifications. Here you can see a SureSine being used in a very well-designed integrated cabinet. A lot of these applications are covered by these more sophisticated system integrations, telecommunications. The 4G and 5G expansion throughout the world is gaining a lot of steam. And it's interesting because the systems are getting smaller. They're more easily distributed across the geography of a country. They're more easily enabled to run exclusively on pure solar power, not require gensets or even the grid. We see industrial Wi-Fi and mesh networks in place all the time for applications such as mining, where they want to bring a network to a site to provide connectivity for their industrial equipment. And then, of course, for ISP backhaul communications. The wireless industry really pushing hard with rural connectivity and broadband initiatives, mainly because of the drive from the global pandemic. Everyone needs to be connected, and these systems can enable that. So you can see many other applications. And one thing to take a note is site AC power for service personnel. When you've got equipment, power tools, you need to service a site, having a little bit of AC power, even in a natively DC system, is an extreme advantage and something we see a lot of customers asking for solutions for. So whether the product is a quick field configuration using dip switches, because most of these are standard settings that can be quickly deployed, or whether you need to actually utilize the mobile app and provide detailed customization of these settings, you have a choice. Detailed using the application, or quick and easy for standard settings. But either way, it's something that customers are really happy to be able to do so. And then lastly, a push here is you can see that we have efficiency that is far greater than an average that's been integrated with competitors. So you can see that typically when you look at Morningstar's overall efficiency exceeding 93% across the entire model, you can see during that compared to competitors, the standby consumptions that can be in effect by some of these products that I would say are not industrial grade can be very inadequate. 88% or anything lower, you're going to be losing a lot of power to those applications. Okay, one of the things I mentioned earlier is the differences in some of these loads. If you look at these applications here, you'll notice that continuous duty loads are something that is pulling power day in and day out. And you need a cool, operating, and of course, very efficient design in terms of providing that power 24 hours a day. But loads that have a high momentary draw, they may be run for a heavier cycle and then turned off. Of course, those need to be stood up. And then, as I mentioned earlier, the ability to provide a high inrush surge, so that current that can start heavy loads, fans, motors. As I mentioned, we use valve controls that are turning on and off pipeline applications. Those are also something that the SureSine, of course, run in the field. The hardwire applications, you can see here, the reason we have both an input and on the top and the bottom is because you have the ability to provide wiring. You can do a pass-through, or if you wish to bond the neutral to earth, such as on the right two terminals, that can be actually done at the inverter. So you can provide a bonded system. It should only be done once in a system, and that can be done right at the inverter itself. If you needed to wire into an existing system, then of course the neutral earth bond would probably be elsewhere. But either way, it's very flexible in its ability to be installed in a system. Fully galvanically isolated, the ability to add, of course, circuit overcurrent protection at any time, and the output can be, as I said, floating, and it is isolated from the chassis, so that your bond to the chassis can be independent of the AC wiring itself, which is sometimes critical for industrial applications. Okay, so that's a really broad overview of a lot of the features on the SureSine. So as I stated, designed for off-grid needs in mind specifically, seamless integration with Morningstar products using RMS CAN bus, more data and integration and control than you'll see in any other product in this class, designed for the applications that we support, and of course a top performer in terms of smooth operation, quality, low noise, and high efficiency. So it's definitely power you can count on anywhere. So with that, I will now refer to Bill Mellame, who's going to be taking over the presentation and talking about our other product, the GenStar. Bill?
Great. Thanks, Brad. I'm Bill Mellame, Director of Product Management here at Morningstar. I want to thank Billy and the folks at Solar Power World for this opportunity to meet with you to talk about our new products. So let me start by saying how excited we are to introduce the new GenStar Solar DC System Controller. This product is the culmination of a lot of hard work, customer input, and inventive thinking. We see it as a new product category in many ways, which we'll get into shortly. There's a lot to cover here in the limited time we have, so we'll be focusing on the most salient points. We'll have some time for questions after the presentation, and materials will be available for download as well that will provide more depth of detail. So before we jump in on the details of the GenStar, I wanted to provide a little background on our charge controller history and the lineage to give you all some context. I think Brad did a pretty good job up front, covering some of our background, but I wanted to cover it in the context of our charge controller history. The slide's a bit of an eye chart, I'll admit, but it does demonstrate our long history of charge controller development, starting with the release of the ProStar back in 1994. The company was founded on a commitment to deliver quality products and to provide a high level of support and service for our customers. And that is true today as it was back then. In the intervening years, you can see we've released numerous families of products that address key needs in the off-grid solar market. We cover the various combinations of power class, system voltage, load control needs, and application types. So the chances are very good that we have a charge controller solution that meets your needs. And we've learned a lot about what works and what doesn't, and where our customers' pain points lie. How to couple our off-grid needs with smart, reliable design that stands the test of time. And many of those early charge controllers are still running strong today in installations in all 7 continents. So the GenStar, as our latest flagship product in the new integrated series, it draws on that experience and the lessons learned and borrows much of the core designs of its predecessors, especially the iconic TriStar PPT. So while the GenStar is a new product, many aspects of its design, at its heart anyway, borrows on the technology with considerable track record in the field. So let me go ahead and cover some of the core features of the GenStar first, and then we'll be able to get into some of the more differentiating features that sets the product apart from the pack, putting it in a product class of its own. First, the oversized arrays. Oversizing the array compared to the capacity of the power conversion equipment has been common practice in the grid tie space for many years. But we're seeing this more and more, requests from our customers on the off-grid space as well. Modules are cheap, The system demands in some cases are increasing, and the customers would really like to oversize the array compared to the capacity of the controller so that the tails, the morning and the evening, have more consistent power delivery throughout the day, resulting in better system sizing and more consistency of power delivery throughout the charging day. Best-in-class efficiency, so ensuring the power conversion losses are kept to a minimum. Every watt counts when you're off the grid. If inefficiency in the power conversion leads to heat loss, which means that's additional heat in the enclosure or the cabinet or wherever the equipment may lie, which then heats other peripheral equipment in the system. Heat, of course, is the bane of existence of power conversion equipment, so you want to reduce that as much as possible. Convection cooling, much like our SureSine line of inverters, you see a nice big healthy heat sink on the front of this guy. No fans. The motto in our engineering group is, if it moves, it breaks. So as an industrial-focused company, we go through great strides to make sure that we avoid fans. We use passive cooling. If we can avoid just one truck roll to the field for a service visit, we've paid for the controller and the extra aluminum for heat sinking many times over in one shot. It supports all battery chemistries. So we've designed this from the ground up, of course, to support the latest in lithium technology, but of course it will support our lead acid and other chemistries in the field. So we provide a brand new charging algorithm that's based off of our old charger algorithm, but we have additional settings and so forth to make sure that you get exactly what you want in terms of charging algorithm. 30 amp load control. This is a really important feature. So a lack of load control is a key cause of system failure and battery damage due to over-discharge conditions in these off-grid systems. It's a pretty ubiquitous problem. So it's pretty unique to have a 30 amp load control or a load control at all, for that matter, in these larger power classes. So from day one, we've got this 30 amp load control built in. It is native to the design of the product and the UI, and so you can set the LVD settings or the on and off criteria based on whatever conditions you require to turn that load on and off in your system without additional accessories or additional load control options. It's available in 60, 80, and 100 amp versions to match your system sizing needs. And this rating refers to the amount of charging current that's delivered to the battery. So in this case, the 60, 80, and 100 amp would deliver 60, 80, 100 amps of charging current into the battery respectively. On the connectivity front, it has Ethernet, 45, and USB isolated communications baked in. And isolation of these interfaces is critical, because if you have a ground loop situation where a ground is accidentally lifted, where there's a miswiring situation, ground can sometimes find its way back through the negative conductors of your communication wiring, which is a lot of current for a very small gauge wire, resulting in burned wires or even damaged interfaces on the product itself. So as a matter of principle, we isolate our communication interfaces to prevent that very problem. Also, the communication front, as Brad had mentioned, with the MS-CAN, that is our new proprietary bus. This allows you to daisy chain GenStars one after another, and with other devices like the SureSine family, without the need for hubs or routers. It also avoids the need for addressing and network configuration. It's plug and play. You just daisy chain them along, and they just work. And then last but not least, I'm sorry about that, just missed the slide here, but last but not least on the communication front is the Wi-Fi and the Bluetooth capabilities. We have a companion app in the works that will interface to the product via Bluetooth and provide a lot of the functionality, or actually the same functionality that the built-in Live View web interface provides, but in a mobile-friendly platform for both iOS and Android platforms. We also have Wi-Fi, so if you want to join the product to a wireless WAN or LAN, you have that option. And every unit that is shipped from day one includes these radios, so it'll come by way of a firmware update shortly after release. So with the top-level features covered, let's now take a look under the hood. Brad had mentioned our use of over-spec components. So we use industrial-rated components applied with very conservative design margins throughout. This is the kind of stuff that does not show up on the data sheet. Our engineering team puts the product through extensive electrical and thermal modeling to ensure all components operate well within the specs and within the stated environmental bounds of the product. There's a switchable four-phase design, which means we basically have 4 converters running in parallel in the product. And this gives us a lot of flexibility in power delivery. So for example, in low light conditions, we can turn off 3 of the 4 phases and only run on 1 phase. This reduces the self-consumption of the product. It increases the efficiency. It also makes it dynamically controllable as the power of the array, and the power production of the array, I should say, goes up and down throughout the solar day. We can turn these phases on and off successively. These are the small things that we do as an off-grid company to make sure that we're maximizing the harvest and we're minimizing the consumption of the system. As Brad alluded to earlier, these little inefficiencies integrate over time. They add up, they compound, and over time, it doesn't take much time before it makes a sizable difference in the balance of the system sizing of your off-grid system. And of course, we pair these converters with our MPPT TrackStar technology, is best-in-class optimization of solar harvest. It allows us to sweep the entire array from the battery voltage to the open circuit of the array and find the maximum power point immediately. The internal thermal paths are a key point here as well. So the power board is sandwiched between 2 heat sinks. We have the main heat sink on the front, and we have a heat sink on the back. And so the power paths are minimized depending on which direction the heat needs to flow. Okay. We have a real-time clock built in, which is central to a lot of the timing features of the software. Because this product is much more than a charge controller, we braked in this kind of logic and time-based logic for scheduling and so forth, so you could decide when certain functions turn on and off based on days of the week and, of course, time of day. We back all this up with a real-time clock and a battery coin cell, so if there is a loss of power in the system, your time is not lost. We have a state-of-the-art processor. Because this is much more than a charge controller, we have a very capable processor in this product. It's doing some very heavy lifting, and there's a considerable amount of software that needs to run to make sure it runs smoothly. We also have a web server and state-of-the-art web app. So this is a little bit different than web pages. So when you connect to the product, it serves the web app in whole to your mobile device, and it runs natively on your browser so that you don't have the lag time and the UI issues that you would typically have with a page-by-page served app. And this LiveView 2.0, as we refer to it, is a powerhouse. It allows basically full application functionality, including the modification of settings, commissioning, data visualization, and more. We have a backlit LCD display baked in. It comes standard with every product. And this is providing the full complement of functionality for on-site administration. So there's some times when you need to be at the system, directly dealing with a unit in the field, for example, changing commissioning or settings and all those sorts of things. We give you that option, all that functionality through the local interface as well. The unique ReadyRail interface, and this is really what sets the product apart when we're talking about, a DC solar system controller. The ReadyRail system allows these snap-in modular ready blocks to mate right to the product itself. So these are going to be able to provide an interesting complement of functionality, which Brad will get into in just a moment. But the idea here is that when you snap in the block, there's nothing more for you to do in terms of actually making that connectivity with that device. It brings alive firmware within the product as soon as that block is attached. And then what you need to do is just simply configure what you want that block to do. And Brad will get into more details on that in just a moment. We have large diameter terminations supporting up to 1-aught cables. It truly does support 1-aught cables. We made sure of this. It has one of the largest apertures in the industry. It may not sound like a big deal, but if you're in the field trying to terminate these very large cables for some hefty or distance battery runs, you need to make sure the cable fits. It sounds like a minor detail, but this was a pain point for some of our customers in discussions. And last but not least is the UL-listed components. So throughout the design, we've used UL-listed components to meet UL 1741 and IEC 62109-1 requirements. So you can guarantee that the product's been built with quality materials, and all those materials are tested within the constraints of the design, and make sure that everything is well within design margins. Now, I mentioned previously that we believe that GenStar stands apart in a new product category of its own. It's not just a charge controller, but in fact has a bunch of smarts built in that allows for full system visibility and control. And the ReadyRail system eliminates the need for many of those external devices and the associated wiring, and at the same time reducing those network headaches and possible failure points in the system. So now I'll go ahead and hand you off to Brad so he can cover the finer details of the GenStar for you and show you how truly GenStar stands apart from the pack. Thank you for your time. I appreciate it.
Great. Thanks very much, Bill. That was good to see all the in-depth discussion about the product, especially the engineering perspective behind it. So really appreciate it. So yeah, as Bill had mentioned, to talk a little bit more about the ReadyRail system, it's really it's an internal bay and bus power and data all combined to give future capabilities to our products, so they can not only grow over time, but they also can be reconfigured in a way that makes them most effective in the application that they're in. And you can see in this case, we've got those bays on the side, and then there are several different different products or models of these blocks that are going to be coming to market. Okay, the first is the Ready BMS, and what this does is provides full closed-loop digital communication with many of the lithium-ion batteries in the market today. And through Morningstar's through Morningstar's partnership program, the energy storage partnership program that allows us to work closely in collaboration between our engineering applications and the development teams at the battery manufacturers, we work on preset, configured, model and manufacturer-specific set points for these batteries. And therefore, when we communicate with them, they're going to perform in the best way possible, with really agreed upon charge settings. They're going to ensure their long life, and most importantly, utilizing as much of the high current capabilities as possible that closed loop lithium battery integration can provide. Okay, so first, that BMS block is the one that's going to be available at release. Another one that will be available at release is the Ready Shunt, and this does take some of the battery capabilities but turns it in a more general purpose towards lead acid batteries, so you can provide state of charge calculations for that technology as well. Energy in and out, so basically net current monitoring of the battery so that everything is accounted for, all the charging in, all of the load draw out, and that can be measured also by the GenStar natively and right on board the controller. And then lastly, you can use current measurement for various branch circuits. As we mentioned, we see one or sometimes multiple DC loads connected to the device. We sometimes see external charging sources beyond solar, such as fuel cells or generators, rectifiers. All of those can be measured using the Ready Shunt. Okay, and I want to remind everyone that as I talk about these blocks, it's not 1, 2, or 3. You can put 2 or even 3 of a certain block type in the product if you want to enhance it in that way. You have a choice of up to 3 bays that you can utilize. And then the last product being the Ready Relay, and that gives you 2 integrated dry contact signals for alarm signaling, auxiliary control, advanced load control, really anything that you would want to switch those relays based on. And there's a very extensive complement of logic and configuration control, which I'll talk about here shortly, inside of the application. So here's an excellent diagram. And again, while there's a lot happening here, and I won't go through each piece, I just want to show you what we mean by integrated DC system control. It's not just the solar charging the battery. It's load management, it's expansion, it's integration, with our SureSine, with other Morningstar devices, other charging sources, such as generators and fuel cells, a sophisticated complement of data connectivity you can see on the top with IP-based networking, web pages, and of course, open communication standards, such as Modbus SNMP. On the right side, you can see some of the system accessories that are enabled, such as the dry contact signaling, and as Bill mentioned earlier, utilizing our real-time clock and Boolean logic. You can set up very sophisticated, purpose-built controls that are automated based on current operating values of the system. So all of that comes together and really gives you a Swiss Army knife of a product that can really do just about anything in the field to meet your needs. So some of the the advantages of what DC system control actually is that you get away from having to buy third-party products, maybe some of varying or poorer quality, to fit in those niche, 5 or 10% of the application that the product couldn't cover. We want to expand the scope of the controller, make it as broad as possible, and give you total system visibility from one device and one remote monitoring connection. So the integrators and installers and designers, when they're looking for these features, they can build the product to suit. It really keeps the system tight. more integrated, and also, save space in the cabinetry as well. Communications, even though there are open protocols available, the more comm lines you've got going in and out of products, the more headaches can be created, and we've really got to minimize that. And having these inbuilt devices, simplifies the system greatly. And then the addition of the live view integration and the mobile app are going to provide even better benefits down the road. So here you can see a dashboard view of the live view 2.0 web app, and this is served from within the device itself. And then you can see that this is actually what's called a responsive app. So this dashboard will configure it, in a wide view for an application that's running on a laptop. It can reconfigure itself to be very vertical in terms of meeting the needs of small screens for mobile devices, tablets as well. Runs in any web browser, regardless of operating system, and really is very responsive and still quite graphically enhanced, considering it runs right within the web. So you can make configuration changes and settings, and we'll explore this in a little more detail here with some of these additional screens. So one of the things we talked about earlier is battery configuration. It's what Morningstar is known for providing excellent support for, from our history many years ago with PWM charging in multiple stages, all the way up to our closed loop integration with VMS interfaces today. And what you'll see is you've got a choice of standard presets that can be deployed rapidly. You can go in and you can custom program your settings. So if you have fine tuning or tweaks that you wish to make to the settings, you can do that on the left, giving you kind of the most standard and most commonly used settings, or you can go into a more installer focused setting list that gives you greater capabilities to adjust temperature compensation and other kind of rare cases. As we mentioned, the VMS integration gives you out-of-the-box functionality for digital comms with a growing list of partners from our ESP program. And then lastly, the advanced settings. And I want to show you that with this web interface, once you make your design choices, your configurations can be saved so that systems can be designed and deployed and redeployed repeatedly with very high amount of accuracy in terms of the settings, and you can save custom configurations and redeploy them with an SD card remotely using the web app, for very, repeatability is really key in the market. Okay, and then going on to the next slide, you'll see some of the visuals here for our scheduler. So when you're showing advanced configuration of load control, maybe a lighting application, when you want a generator to run in the system, when you're going to be disconnecting loads, maybe you have high priority loads and lower priority loads and want them to run in a certain way. This scheduler enables all that. It is utilizing a real-time clock with backup, and it's a 7-day schedule, meaning it's not one day after the next. It actually gives you the ability to have different schedules for possibly the weekdays versus the weekends, or if you want something to only occur on a single day. You can also combine that conditional logic, as I said, to make exceptions, or maybe only occur when 2 conditions are met. And then, as I mentioned before, the reuse of all these schedules also can be programmed into the settings specifically. Okay, so just to summarize on the GenStar, it is designed for oversized arrays, giving expansive capabilities for oversizing, which is a really strong need in the industry throughout, both grid tie and off-grid. The powerful load control options are really unique in a product of this capacity. And not only inbuilt load control of 30 amps, but the additional capabilities of adding other loads externally, 2 or 3, for kind of a multi-tiered disconnect. It's expandable to meet custom needs of your system. You don't need to integrate a lot of extra third-party equipment, which has its complexity and, of course, points of failure. The advanced battery management is among the best we've ever offered in terms of product coverage for any chemistry that's in the field. And again, utilizing the talents of our application support team is something that's going to grow dramatically in the coming months and years. It provides hybrid system management, which we're seeing a lot of in applications. And of course, a single point where you can access all of the data of the system from one connectivity point, either serial or remotely over IP. So that class-leading efficiency and user interface is something that this product really is going to become known for. Okay, that is everything for my portion of the presentation. So thank you very much. Now I would like to go back to Billy, who will be taking us through the Q&A session. Billy?
Yes, that's right. So we'll take questions until about 1, maybe a minute or 2 over. given the length of the presentation. So yeah, we're going to open up the floor for some questions. Remember, you can continue to submit them at any time in the Q&A widget. First on deck, are the circuit boards protected for environmental effects?
Yes, I can take that one. So we have a conformal coating process that we apply to all of our circuit boards. So depending on the product in our family, it may be encapsulated in epoxy. But for the products that we're discussing today, the circuit boards are applied with a conformal coating process that's actually machine controlled. So the conformal coating is a very thin, translucent layer that is sprayed over the circuit board and all the associated parts, so that if there's condensation or bugs or whatever that maybe happen to be walking across the circuit board, it prevents those short circuits at the board level. It is applied by machine so that it has uniform thickness, and it's quite thin actually in how it's applied. But the reason we do this is if the conformal coating is applied with inconsistent thickness, it actually applies thermal stresses and strains to the components, which can lead to component failure over time. So it's a bit of it's quite scientific in how it's applied, but these are the types of automated machine control processes we employ at the production level to make sure that it's consistent quality and reliability.
All right, great. Are the Android apps available and downloadable?
Right. So for both products, we will have for the inverter family, we will have the app concurrent with release of the product and availability. For the GenStar product, we're expecting early next year availability for those apps. But for both products, we'll be supporting both Android and iOS.
Awesome. With Bluetooth connectivity, Wi-Fi, etc., on components, how does that affect system security overall? Isn't that critical with commercial solar systems?
Right. So this is a particular pain point that customers have brought to our attention, especially for some of these industrial systems where security is paramount. The user wants a proof positive verification that the wireless radios are turned off after they've connected the unit, done whatever service they required, and they want to make sure those radios are turned off before they leave the site. So in those cases, and for both products actually, we have user configurable or adjustments right on the unit itself. On the inverters, we have a dip switch, and on the GenStar, we have a button, a soft key right on the button, right on the front of the unit rather, that allows you to visually confirm that the radio was turned off for security purposes. So that's something that we're very cognizant of. Yes.
All right. Is the hardware installation option available in all power ratings or only the higher ones?
All power ratings.
All right, great. Let me see what else I've got here. Are the screw terminals marine grade stainless?
It depends on how you want to classify marine grade. So the terminals on the GenStar and on the SureSine family are aluminum terminations, but they are plated, tin plated, I believe, in most cases for anti-corrosion and anti-oxidation from the air.
All right. Your blocks on the GenStar, can you use them singly? Can you use them together? How do you configure them?
That's a good question. I probably should have covered that in more detail in the presentation. So the blocks can be used in whatever combination you see fit. So if you want, for whatever reason, to have 3 ready relay blocks providing up to 6 dry contacts, you can do that. If you want a BMS block and 2 shunt blocks for 4 shunt inputs, you can do that as well. It doesn't matter what order you stack them in. It doesn't matter what combination you stack them in. The flexibility is yours to suit it to your system needs.
All right. Have you published curves showing efficiency at different loads?
Right. So as Brad had mentioned before, we do provide the thermal information, including efficiency curves, the D-rate curves, and so forth, along with additional thermal information so that you can make the right system design decisions for your system. This is part and parcel of our product release process. These items are not available online yet, but we are compiling this information so that that information is available to you when the products are available.
All right, and apologies if I don't get this one exactly right. I'm trying to get the wording correctly, but for lead acid SOC, is the ready shunt necessary? A basic LED SOC readout is not included in the GenStar without ready shunt.
Right. So the GenStar has the traditional 3 LEDs, for state of charge based on voltage alone. That has not changed. That is still consistent. If you want to have the closed loop communication with one of our lithium battery partners, the BMS block provides that communication link directly to the BMS of the battery, in which case we have native information about that battery back at the charge controller. That allows us to charge to the battery's requirements, but it also allows the user access to that data so they can make decisions in the logic, for example, based on that BMS information. It's a very powerful pairing. We're very excited about this feature.
All right, awesome. Well, I think that's all the time we have for questions today. I saw several just come in the last minute. So if you have additional unanswered questions, please feel free to contact our presenters on your own. This webinar will be shared with all registrants, so you may view it again at your convenience. I'd like to thank Bill, Jim, and Brad for being here, and of course Morningstar for sponsoring today's webinar. And thank you to everyone in our audience for participating. I hope you enjoyed the presentation, and we invite you to join us for more Solar Power World webinars in the future. Thanks, everyone.
Thank you, Billy.
Thank you.
Thank you.